just come back from the first meeting. I think she has now the best person, she's the best person in this room and globally where we can have the latest updates about what is the data and science of cities and climate change. The floor is yours. Welcome. Teşekkürler. Hoş geldiniz.
Thank you very much, Yunus. Thank you very much, everyone. Herkese merhabalar. First of all, thank you for the invitation to this workshop on World Water Day for tomorrow, March 22nd. I'll be focusing towards IPCC's special report on climate change in cities, but it's an introduction focusing also on the importance of water and the nexus of water and climate change. So on the water chapter from the latest IPCC report, water-related risks are projected to increase with every degree of global warming. Limiting global warming to 1.5 degrees Celsius in the long term would reduce water-related risks across regions and sectors. And future projected adaptations for water, for example, are effective in reducing risks, but to a very varying extent, so there are limits to adaptation. And effectiveness falls sharply beyond 2 degrees Celsius, emphasizing the need for limiting warming to 1.5 degrees Celsius. And it is possible to meet the triple goals of water security, sustainable, and climate-resilient development. One of the key findings coming from Working Group 1 was that whether it's extreme heat, heavy precipitation over land, or agricultural and ecological droughts in dry regions, the frequency and intensity of these extreme events do increase with every single increment of global warming, and very significantly so at every additional 1.5 degrees Celsius of additional warming. And here we see how much the frequency and intensity of these extreme 10-year events increase in 1 degree Celsius, where we're currently at almost 1.5 degrees Celsius, which we're closely nearing 2 degrees Celsius and 4 degrees Celsius. So the choices that we take now and in the near term are very valuable for many generations ahead and determining our climate future. There's not a single climate future, but that climate future depends on the actions that we take now. On the right-hand side of this figure, we do see the more positive image of the future, where human activities contribute to protecting, conserving, and restoring ecosystems, with many decarbonization options as we see here, and for climate-resilient development. Many of these also relate to what we do in cities, such as green cities and settlements, human well-being, low-emission energy production, water security, and much more. So, even in this picture, and others that are included in the latest IPCC findings, we do have the opportunity to go towards a more relatively positive image of the future. Yes, there will be climate change, but our mission is to do everything we can now, and there's a tremendous role for cities in what they can do. If we look at cities as both a challenge and a key aspect of the solution, we do know that the global share of emissions that can be attributed to urban areas is increasing. In 2015, urban emissions were estimated to be 25 gigatons CO2 equivalent, and in 2020, this had risen to 29 gigatons CO2 equivalent. And this is about 67–72% of the global share, excluding aviation, shipping, and biogenic source of emissions. If the current urbanization trends continue, we do know that this 29 gigatons CO2 equivalent in 2020 could increase with only moderate mitigation efforts. And this could be 34 gigatons CO2 equivalent. And with only low mitigation efforts, even 40 gigatons CO2 equivalent in 2050. But it is only with ambitious and immediate mitigation efforts, including high levels of electrification and improved energy and material efficiency, that urban emissions can be reduced to at most 3 gigatons CO2 equivalent in 2050, and this includes both CO2 emissions and methane emissions. So one of the key findings that we had the privilege of working on, also in the 6th assessment cycle, was that urban areas can create opportunities to increase resource efficiency and significantly reduce greenhouse gas emissions through the systemic transition of infrastructure in urban form through low-emission development pathways toward net-zero emissions. And we might ask, why are urban areas creating these systemic opportunities? It's because all the sectors, the people, the environment come together in the urban areas. So when we look at urban systems as a key aspect of the solution, ambitious mitigation efforts for different types of cities. These can be established, rapidly growing, and emerging cities across the world. The three main areas or main strategy areas are reducing or changing urban energy and material use towards more sustainable production and consumption across all sectors, including through compact and efficient urban forms of supporting infrastructure, electrification in combination with switching to low-carbon energy sources, and enhancing carbon uptake and storage in the urban environment. When we look at compact urban form, here on the left-hand side, we see different types of urban activities. This can be residential, commercial, and this is the pattern that we see in the middle, and surrounding carbon sinks. When urban areas with all of these functions are more compact and relatively more walkable, it is possible to also protect the surrounding carbon sinks. Whereas if it is more dispersed and autocentric, where we have to use cars most of the time for traveling across the city, then urban carbon sinks are not as protected. So compact and walkable urban form has many co-benefits, including co-located jobs and housing, mental and physical health, lower resource demand, and saving land for agriculture, forestry, and other land use. So the food security can also be saved with this type of more compact and efficient urban form. And when we look at urban areas, there are layers of different sectors. You have land use, in the very bottom, you have transportation, buildings, and energy, all coming together in the urban systems. For example, better urban planning and service provisioning in the land layer has the potential to reduce energy demand by 20-25% in 2050 alone. And this is through the efficiency in the transportation, the buildings, and when the energy layer is also electrified and decarbonized, this mitigation potential also increases. So electrification of energy and fuel systems in cities and efficient demand can mitigate 6.9 gigatons CO2 equivalent by 2030 and 15.3 gigaton CO2 equivalent by 2050. And decarbonization increases this share. When we look at consumption-based emissions, urban areas are also connected to other urban areas across the world, other urban areas in the region, and also to land patterns. So the full potential for reducing consumption-based emissions to net zero greenhouse gas emissions also takes place when emissions beyond the city's administrative boundaries are also addressed. So it is possible that the multiple mitigation options that urban areas have, especially when they are integrated, can have cascading positive effects across transport, energy, buildings, land use, and behavior. When we look at a more matrix arrangement with the urban growth typology, so emerging areas, more rapidly growing areas where infrastructure is still being rapidly built, and more established urban areas, each of these colors and the concentric circles represents special strategy. For example, when we're looking at emerging rapidly growing urban areas, spatial planning, urban form, and infrastructure, those strategies are very important. But when we look at more established cities, most of the infrastructure is already there. What can we do? It is the electrification and net zero emission reductions that is the forerunner in these types of strategies. So depending on the types of cities, there can be different entry points and sequencing of mitigation strategies in an integrated manner to capture all of those opportunities that are available. The urban mitigation options also have many synergies and benefits for sustainable development goals. And for example, promoting walkable urban areas combined with electrification and renewable energy can create healthful benefits from cleaner air and benefits for enhanced mobility. Case studies. This was done in the sixth assessment cycle, but when we're speaking about the special report, the upcoming report on climate change in cities, case studies will be a very important role. So not only showing case studies that we see here, which is coming from Working Group 3, many more case studies will be included. Working Group 1, which is representing the physical science basis, also has a role. For example, there are many more findings on cities, their relation with water cycle, and maybe even advancing beyond the findings that are already there. So coming to the special report, I would like to also indicate that there are 5 chapters. The outline of the special report was agreed in Sofia, Bulgaria scoping meeting that was held in Riga, Latvia. And the 5 chapters looked into cities in the context of climate change, framing out the report, cities in the changing climate, looking at the trends, challenges, and opportunities. The 3rd chapter looks into actions and solutions to reduce urban risks and emissions. The 4th chapter will look at how to facilitate and accelerate change. And the 5th chapter will look at solutions by city types and regions. And as I mentioned, this is very important because many of the cities learn from one another. What one city is doing also is an inspiration and a source of information to inform what other cities are doing across the world. From the perspective of urban areas and the mitigation of climate change, I would like to share that the upcoming report has very important bullets. These include urban emission trends, including consumption-based emissions, the role of cities in emissions and mitigation, future global and city-level scenarios, considering local options, equity, sustainable development, infrastructure, and informal settlements. And this will be covered in Chapter 2 of the report. Coming to Chapter 3, using the already existing knowledge base of what can be done in cities, a very important bullet for the guidance for the authors looks into common and context-specific urban mitigation options for spatial planning, energy, including heating, cooling, and electricity, existing and new buildings and infrastructure, mobility and transport, water, land, food, demand-side measures, and behavioral change, and cross-sectoral, integrated approaches in urban systems, such as circularity. So all of the promising opportunities in urban areas will be again assessed based on the latest findings in the scientific literature that is continuing day by day, month by month, and year by year. From the perspective of urban areas and the adaptation of climate change, the report will also cover urban adaptation and disaster risk reduction options for managing risks in natural, ecological, and human systems, including but not limited to physical infrastructure, urban nature-based solutions, and ecosystem-based adaptation, and planning and social policies such as relocation, health systems, and early warning systems. When we look at the decision that was taken in Sofia, Bulgaria, that is now guiding the authors and the authors that just came together last week in Osaka, Japan, to come together in the first author meeting, they are taking this outline, agreed outline by the governments as their guidance, as they structure their report. So this is the first part of the Chapter 3 bullets. There is more, but I would also like to mention that it includes the evaluation of city actions across mitigation and adaptation, including responding to loss and damages, such as reconstruction and rehabilitation, including lessons learned, effectiveness and feasibility, mitigation measures with baseline emission inventories and targets adopted by cities, and many more. At this point, it's not possible to talk about the content of the report that is already taking place. This will be available in 2 years, by March 2027. So at this point, I would just like to go over the contents in the outline and just give more examples of the bullets. So from the perspective of urban areas again, this also looks into metrics for assessing mitigation and adaptation options in the context of sustainable development and the characteristics of and within cities, including service provisioning that delivers health and well-being for all. For example, again, in Chapter 3. When we look at the other chapters that are being developed, the holistic planning and systems thinking approach towards decarbonized and climate resilient cities will also be emphasized, as well as the synthesis of solution relevant information and the collection of case studies by city types in the context of urban sustainable development. And I would like to once again emphasize why is this important for the case studies. A cross-working group effort already found that the diversities of cities' experiences of climate mitigation and adaptation strategies brings an advantage for those city governments and other actors willing to learn together. And this can also include, especially for the Muğla region, sustainable urban planning and infrastructure design that includes green roofs and facades, networks of parks and open spaces, management of urban forests and wetlands, urban agriculture, and water-sensitive design that can deliver both mitigation and adaptation benefits in settlements. So coming towards the end of my presentation, what is the audience? The audience of the special report that is being worked on by the author team is focusing all kinds of decision makers at national level, at local level, all across the world, the city networks, including IKLİM, for example, and the targets that such city networks also have for other urban areas across the world. So, for example, how can cities work collaboratively to achieve carbon neutrality in cities in the next 10 to 20 years? How is it possible to move from planning to implementation and unlocking climate finance at the local level, and many more? So the audience does include the city networks, and it also includes the national government. For example, this is coming from the UN Habitat report, looking into local action for global goals, and the urban content and nation-determined contributions is very marginal across the world. In Turkey, we are among the governments and countries across the world where our nation-determined contribution does have a very high share of urban content relative to the others. But all across the world, currently 39% of nation-determined contributions have moderate urban content, and 34% have low or no urban content, and only 27% include strong urban elements. So in the next 2 years, by March 2027, when the special report on climate change in cities is accepted and adopted by the government after a very intense working schedule of the author teams, we do look forward to sharing more updated results with you and to make a change in our climate future. Thank you very much for your attention. Çok teşekkür ederim. İyi günler diliyorum.
Thank you, Dr. That was, I forgot to mention at the beginning of my introduction to the session, we have in this audience a diversity of scientists and experts, both from universities, from Ankara, Istanbul, Muğla, but also the city practitioners. So the audience is exactly the type of the information that they would like to be hearing, and I think that was an excellent presentation. Maybe good to underline two things in that discussion. First of all, for a long time, this was an arbitrary discussion. It was scientists that was mainly on the climatology level, but here you can see the discussion going to the engineering, anthropology, urban planning, so they are much more now bringing this type of experts into the process. The second point, and that was really our success, there is a number of opportunities that the staff and the scientists that are at the city departments were also able to contribute in this consultation. So we nominated experts from Rio, Turku, Durban. They are now part of the drafting committee, so that the city scientists who are in these departments, they can also contribute and especially bring the grey literature, which is not always very scientifically recorded, but through this opportunity we can bring much more information and bring the same thing back to the cities as well. And maybe finally, I think the thing that we are so excited is that, if you have remembered from my presentation in the beginning, the IPCC is an authority. Any report from IPCC is taken to the climate conference of parties, and the parties adopt decisions. So when we already say that it's a multi-level climate planning now, the authoritative findings from IPCC will give us the chance that the new climate plans will be much better informed by cities and in urban development, and back to the investments to the city as well. So it's a really exciting process, it's a complex process, and we're really wishing you the best. And I think there will be more opportunities to contribute, because IPCC will be giving some more calling for inputs and review process. So we're just at the beginning, and it's an exciting journey. So now we'd like to go to our next speaker, Dr. Chris Hewitt, Director of Climate Services at World Meteorological Organization. It's the authoritative body for the scientific information on climate and meteorology, and of course one of the founders of the IPCC. Dr. Chris Hewitt will give us information about climate information for decision making. The floor is yours, Dr. Hewitt.
Thank you very much. I think I shared the wrong screen. Bear with me. Apologies for that. Can you see?
Yes, we see your screen.
Good, thank you. Yeah, I'm delighted to be following IPCC. Very privileged, and thank you very much for inviting me to this workshop. Apologies I can't be there in person. So I am at the WMO, the World Meteorological Organization, where I'm the Director of Climate Services. I'll explain these terms shortly. and I'll be talking about climate information for decision making, so very much building on Sia's talk there. I'm conscious you might not be familiar with the WMO, so very quickly, the World Meteorological Organization is the UN specialised agency for weather, climate and water. We have member states and territories all around the world, including Turkey, a very important member. Primarily, we're here to support resilience and sustainable development of all nations, particularly the most vulnerable, but all nations. And we also define best practice and set international standards for weather and climate. And as Ulis just mentioned, WMO and the United Nations Environment Programme established IPCC a long time ago, in 1988, so we're very proud of the achievements and the progress and the importance of IPCC, particularly, for example, in the COP process. So that's WMO. Climate services, so that's the name of this session. So very quickly, it's providing and using climate information to assist decision making. And there's a whole range of climate information, and there's a whole range of decision making. So it is a very broad topic. It's recognised that climate information is becoming increasingly important and relevant for decision making across society. There are many, many more stakeholders, groups interested in having climate information. There's a very active scientific underpinning basis for developing information, and there's many people trying to deliver that information to help decision makers and policy makers. So this was recognised in 2009 at the World Climate Conference 3, where heads of state, governments, industries, scientific experts all came together in recognition of the importance of developing, delivering and using climate information for decision making. These World Climate Conferences are big deals. They ultimately led to the establishment of things such as the IPCC, for example, UNFCCC, the United Nations Framework Convention on Climate Change, a whole range of important activities. So the most recent one in 2009 was a global framework for climate services, so helping countries all around the world develop, deliver and use information. The pictures on the right illustrate some of the case studies, some of the use studies. So at the bottom, for example, that's the 3 Gorges Dam in China, the world's largest, I think it's still the world's largest hydropower dam, and they use climate information for operating that dam. So there is many, many important use cases. The WMO itself, so we are made up of members, so it's our members, so in Turkey, the Turkish Met Service, universities, various other organisations actually deliver the climate services within the country. And so the WMO works with organisations all around the world to help them deliver the climate services. So the WMO is not an operational climate service provider. But there are some important services that we do provide to the global community. And this figure here shows the climate reports that we produce. We regularly produce climate reports, and so at the top left we produce a global state of the climate report, and I will say a bit more about that shortly. At the bottom left we also produce regional reports, so the European region, which here is in, they have a regional report every year which gives the state of the climate in the previous year. IPCC operates on much longer timescales, every 5 to 9 years typically. And so these annual updates are very important in between the IPCC assessment reports. So the European State of the Climate Report will be launched in a few weeks' time, actually. So ECMWF, we will hear from shortly, and the WMO work together with many partners around Europe on the European reports. We also produce an annual report on the state of climate services, so looking specifically at what progress there has been with the climate service development, delivery and use in nations around the world. And this year we're looking to provide information in time for COP30, particularly on nationally determined contributions and so the role of climate services in NDCs. And at the bottom right, we also produce more regular updates, more than once a year, so we produce information about ENSO, so El Niño and La Niña. We provide regular updates on the state of ENSO. And then we produce a forecast, a high-level forecast for the coming 5 years in consultation with various groups around the world. I'll to answer questions on those later, but I'm now going to focus on the state of the climate. So the reason I'm doing this is it came out 2 days ago, so this is very timely. This is almost literally hot off the press. And so the WMO's working with experts all around the world, and so we look back, we monitor the state of the climate, and as we just heard from IPCC, they then provide essential information for the future possible projections of climate to feed into COP. So there's sort of a synergistic role here. So every year we update on the state of the climate, and so 2 days ago we launched the state of the climate for 2024. And it's not good news. There's no other way of putting this really. So the most recent greenhouse gas figures we have rather confusingly are up to 2023. The rest of these graphs I'll show will be up to 2024. So the atmospheric levels of carbon dioxide, methane and nitrous oxide reached the highest levels in at least the last 800,000 years. So we're continuing to see increases in greenhouse gas emissions, and the IPCC then makes projections based on future scenarios of greenhouse gas emissions. So in terms of observing, greenhouse gas emissions are continuing to rise, and that's largely driving the long-term warming that we're seeing in the climate system. So this graphic here shows 6 observational data sets that we used, including one from ECMWF. So there were 6 big data sets we used globally to look back. We go back to 1850 to look at the global average near surface temperature year on year. So unfortunately, we reported in 2023 that 2023 was the warmest year on record, and now we're having to report that 2024 has beaten the 2023 record. And so 2024, the warmest year on record, at 1.55, that's 0.13, so there's some uncertainty in these observation data sets, but 1.55 degrees centigrade above the pre-industrial reference period, 1850 to 1900. So that's not good news. You look at the graph and you can see the last 2 years in particular really stand out. But the last 10 years, if you look at the most recent 10 years, the top 10 warmest years are all in that last 10-year period, and that's never happened before. We've never seen such a prolonged period of warming. It's really quite striking. So that's the global average, and then if we break it down to look at the distribution across the world, focusing on where we are, of course, in Europe. So this is the temperature difference for 2024, and red is warm. And so there are large parts of the world where we can see warming, particularly over land, and sadly, particularly in the northern hemisphere, in large parts of Europe and North America and Asia. So there are some parts of the world that cool slightly, but the overall picture is quite a dramatic warming. So I've said the 1.55 number, and of course that then, and so you see us talk as well about these different numbers which are specified in the Paris Agreement. So the Paris Agreement says to hold the increase in the global average temperature well below 2 degrees centigrade. There's 2 efforts to limit it to no more than 1.5, recognising this would significantly reduce the risk and impacts of climate change. So we've heard in the previous talk about every fraction of additional warming causes problems. 1.5 is not great, but 2 is even worse, and so we really do need to try and limit this number as much as possible. However, even though last year, 2024, was 1.55 degrees above pre-industrial, that does not mean the same thing as having exceeded thresholds or levels mentioned in the Paris Agreement. So the Paris Agreement refers to long-term averages. So the IPCC would specify this as decadal averages. So 10, 20 or 30-year average. So an individual year does not mean that long-term warming has exceeded 1.5 degrees. However, we're now working very much to try and actually be able to monitor where we are with regards to the Paris Agreement. So we've established an international team of experts to define a metric for this, and we're looking at various different scientific approaches around the world at the moment. That's the figure on the right. And so, the very bottom of that figure, if we look at IPCC, the 6th assessment report, so the most recent report from a few years ago, the method specified in there is to look back at a 10-year average, so the most recent 10-year period, so that would be 2015 to 2024, and the level of warming would be in the middle of that period, so 2019 is the middle of that period. So the warming of 2019, averaging over those 10 years, would be 1.25 degrees industrial. The problem with that metric is, because it's centred on the middle of that 10-year period, you look back over the last 10 years, you're saying this 5 years after the fact. So we can say now that 2019 was 1.25 degrees, but that's 5 years too late. So we're looking at other ways, can we try and centre that number on the most recent period? So perhaps just the top numbers one, for example. So we could look back at the observations for the last 10 years, and then look forward using climate models as a forecast of the next 10 years to give us an average of 20 years centred on 2024. And there's various other methods of doing this. All of those give us a best estimate that we've not yet reached 1.5 degrees. Somewhere in the 1.34 to 1.41 range, we're trying to narrow that down. So good news, we're not at 1.5 degrees, we don't believe. Bad news, we are getting closer and closer, and we shouldn't pretend we're not. We are clearly going in the direction of exceeding 1.5 degrees. And the figure of the greenhouse gas emissions shows that concentrations in the atmosphere continue to rise, and so the warming will continue. I'll now quickly race through some other metrics, if that's okay. So, looking at Antarctic and Arctic sea ice extent, so Arctic and Antarctic sea ice extent were both below average in 2024. Antarctic has been interesting. We didn't see any obvious reduction in Antarctic sea ice extent for many, many years, but particularly the last 3 or 4 years, the last 10 or so years, we have now seen a reduction in Antarctic sea ice extent, and for the Arctic there's been a gradual reduction over a long period. And that's not surprising if you warm the atmosphere. So on that note, if you then look at glaciers around the world, so you warm the atmosphere, there will be some regions where the glaciers could grow, but you would expect on average any level of warming would melt the ice. And so sadly, indeed, glacier mass loss, glaciers have been losing mass for many, many years, and the last 3 years in particular have been very notable as the amount of ice we've lost from the glaciers around the world. Warming the atmosphere, warming the ocean, so we're seeing the ocean heat content is increasing dramatically over the observation period of this, going back 65 years. In 2024, reached the highest ocean heat content in the observational record, and the rate of warming over the most recent 20-year period is more than twice that observed at the beginning of the period. So we're seeing the ocean continuing to warm, seeing ice melting, and both of those then influence sea level around the world. That's the most worrying for coastal communities. So last year, the global mean sea level reached a record high in satellite record going back to 1993, and as I said, that's clearly worrying. And ocean heat and sea level, these changes are locked in for centuries, if not longer. Even if we start to reduce the atmospheric greenhouse gas concentrations, we'll continue to see the ocean heat and the sea level rising. We also look at extreme events all around the world, so please, if you're interested, look at the reports after this talk and you'll see a supplement on extreme events around the world provided from many countries. So zooming in on our region here, so last year, many, many deadly heat waves around Europe and other parts of the world, but I'm sure we're all familiar with the experiences in Europe. And so I think this is my final slide. And so I say we also report on the state of climate services. So in 2023, we did the state of climate services focusing on the health sector, so allowing into cities and to heat. So extreme heat causes the greatest mortality of all extreme weather. I think most of the headlines we would see in the news, we probably see pictures of flooding and not so much of heat waves and death from heat waves, which is interesting. Maybe it's because it's a slow onset situation, but there's an estimated 489,000 yearly heat-related deaths over the period 2000 to 2019. 45% of those in Asia and 36% in Europe. These numbers are staggering. And the third bullet point, heat waves and deaths arising from them are very difficult to actually get a handle on. Often the death certificate won't list heat wave as the reason for death. So there are estimates that mortality could be 30 times higher than what is recorded. So that's not good. Some signs of some good news. So heat warnings, they're provided in only half the world's countries. So there are heat warnings being provided in countries. More needs to be done. Only 26 countries have climate-informed heat health early warning systems. But under the UN system, the UN Secretary General a few years ago launched the Early Warning School Initiative to ensure that everyone on Earth is protected by early warning systems by 2027. And heat is one of those key areas where we're looking to provide much better early warning systems. So early warnings and climate services, so climate information for decision making, are vital to protect communities and economies, protect the cities, protect our infrastructure. So I will end there, and thank you for listening, and I think these slides will be available when you have the links to the reports that I've shown.
Excellent. Thank you, Dr. Hurt, for this very, very valuable, and I think you can hear that us, we are probably one of the privileged audience who were able to receive the latest findings just 2 days later. So thanks for that, and maybe I can remind you on one opportunity here in this city of Muğla. is the recently established climate department is currently led by an engineer who has a background on meteorology for 20 plus years. It's one of the very unique cities probably who really understand what is the services, benefits, and opportunities through WMO. And maybe Cihan can be one of those pioneers who can really bring the cities and WMO discussions closer and bring some good practice on how things can be improved better. And I also look forward to our scientists in the morning. They have given us very, very valuable discussions on the Mediterranean basin. So that will be very interesting opportunity of exchanging further information. Without further ado, we are delighted to have our third speaker, and I hope he will be flexible by this 15 minutes of delay. I know he has been waiting in this room, but we hope you still have your time available for us so that we can continue. Our audience are here, none of them has left, so we're still ready for you, Dr. Vincent Henry Posch, Director for Engagement with the EU, European Centre for Medium Range Weather Forecasts, on how can Copernicus help with adaptation and mitigation. It was already addressed, the value of Copernicus was already addressed in the morning, so now we will hear directly from the Copernicus update. So thank you very much for your time, the floor is yours.
Thank you very much. Can you hear me and see the slides?
Excellent, all good from here.
Thank you. Thank you. First of all, thank you very much to the City of Dünya for the invitation. I'm sorry I couldn't be with you in person, but I'm very happy to be there. Just to remind people in the audience that Turkey is one of the ECMWF member states, and it's very important for us to work together with MULA, but with the whole of Turkey, because you're part of ECMWF, and it's a big value for us. So today my talk will drill down, and actually it's very good to show the two previous presentations to show you an example of actual range of climate services that are provided through the Copernicus program. So it will be a bit more hands-on and applied at what you've seen, but also an opportunity for practitioners in the city level to see what's available today, almost at a fingertip, to develop and to optimize strategies. So first of all, if you people in the audience don't know about Copernicus, it's a program of the European Union. It's about combining observations with models to provide value-added services on climate, which is the main focus of today, but also on a range of compartments of the Earth system, ranging from the atmosphere, land surfaces, marine, etc. And for that, it's composed of a part of launching new satellites. So these satellites are called the Sentinels, and maybe you've heard about these, and developing services to provide data to the whole world. In fact, it's an operational program, and the characteristic of the program is to provide all this data free of charge and understanding to anyone in the world. And ECMWF plays a substantial role in the implementation of the program because we manage two of the Copernicus services, the one on climate, which will be the main focus of my presentation today, and the one on atmosphere, which includes greenhouse gas emission, and is thus very important for the mitigations aspects. But by no means the atmosphere and climate services are only implemented by ECMWF. Quite the contrary, we are based on a very wide basis of institutions that work with us to provide this information. So without further ado, let me go into the climate change service and its offering, which is particularly relevant for adaptation, for supporting adaptation strategies. So the climate change service, or C3S in short, looks both at the past, and there are two components to look at the past. It's about using observations, and the other key product of the C3S is to deliver reanalysis, and I will explain quickly what it is. And then C3S also provides information on the near future in the form of seasonal forecasts, but also brokers access to climate projections, which are of course very useful also to develop the best strategy. So C3S has a foot in the past and in the future, and so it helps defining in the present the best possible strategies from the global scale to the national scale to the city scale. First element where C3S is active is to provide a comprehensive record of what is called essential climate variables. So these essential climate variables are defined by the WHO under the GCOS program. And I don't have time to go in lots of detail, but what you can see in terms of small rounds are the different essential climate variables that can be monitored from space. So that's quite a lot. That's the one in green. The one in red are the ones where C3S is working currently to bring them also available to the users, and the orange one are the ones that can be provided through the reanalysis. So what is the reanalysis? So one example, before going to the reanalysis, one example of that, and Chris already mentioned glaciers. C3S provide access with latest information on the glaciers. So this is information up to last year, 2023. For glaciers in Europe, and the figures were really very concerning, not a surprise, but very concerning. For instance, between 2022 and 2023, glaciers in the Alps lost around 10% of their volume in just 1 year. So it's the essential climate variable is a component of C3S based on observation, which then feed their way into wider reports like the one that Chris mentioned. The analysts, what they are, the analysts are to reuse the weather modeling systems and to reprocess data as far back as possible. So in the case of C3S, the current best analysis is called ERA5. It goes back to 1940, so it provides 80 years of data. In the beginning, it's mostly based on conventional data from the ground, and increasingly from the 70s, 80s, 90s, also from satellites. So it allows to have a full gridded data set of the 80 years, completely consistent. And on the curves that Chris showed, you can see that this reanalysis over the last period compares very closely with the pure observation-based other products that are already also compiled by the WHO. The added value of the analysis is that these are maps with no gaps, so that you can do a lot of things with these, because it's just like weather charts, except that it covers a very long period. So it's very useful for a number of applications, and I will show you how you can access this information. The other products of C3S, looking very quickly, are seasonal forecasts, so going over the next 6 months. What C3S has added to the panorama is to join forces with European entities, but also worldwide entities that do seasonal forecasts, so that users can have in one place all these forecasts and can build products based on these forecasts, which cover some are produced in Europe. You can see the Met Office, Meteo France, CLCC in Italy, CNWF, DEW in Germany, but also we have the data from NOAA in the US, Canada, Japan, and coming very soon from Australia. So it's a one-stop shop to get access to seasonal forecasts, which are also very important insight for the future. And then what C3S does with projections, global and also regional, is to broker access. Now, as you know, for scientists, access to CMIP or CORVEX data is straightforward, but for a wide range of users, it's quite complicated to dig into this data. And what the work that C3S has done there was to facilitate access to a wide range of users to these projections. So how does this work in practice? So here I will give 2 examples of how C3S support European institutions. You can see here the European Climate Data Explorer. There is a link below, so you can go and have a play. This is an application that was defined with the European Environment Agency to allow exploration of indicators at the pan-European level and at a fairly granular level of small regions. It's so-called NUTS2, which are 240 in Europe. And you can get a lot of statistics statistics and information about this. 37 indicators, and I can only invite you to have a go and play with this with it better. Another example which I think is very important is the support that we provide to the European Investment Bank that is basically bringing together the hazard matrix, which comes from the C3S monitoring of the evolving climate, with the sensitivity matrix, that is the impact of climate on different topics. And then the European Investment Bank can evaluate the associated climate risk and also fine-tune and target their investment in the best possible way. So it's a very practical access to data that is possible. What is the added value of C3S is also to put a clear focus on evaluation and quality control. So it's not just about making data available, it's also providing the users with all the information and caveats with the use of the data. And we have a very elaborate framework, and you can read also in this paper from the BAMS on how, what is the approach to evaluation and quality control. My final word about C3S is to say that the proof is in the pudding, so you are very welcome to go on the climate data store. There is here the address, and retrieve information or work with the information that is available from C3S. ERA5 is one data set, but they are not. If you are less technically versed, however, they are also a more easy to use application for a quick look or for having a first approach at the data. I have 4 examples that I will jump through very rapidly. One is the climate pulse, so it's accompanying our annual and monthly bulletins, so really showing how the current months or the past months compares to the climatology, and you can play and see a lot of very easy to do maps. Something which is a bit more elaborate is the Climate Atlas, which was elaborated on the basis of the IPCC Atlas, but updated with also with more recent information from the climate monitoring. So we invite you to have a go and play also with the Climate Atlas. Another one, Chris had a slide on the 1.5, so we have an application about looking at global trends, and with regard to the 1.5, but with regard to other things as well. And the latest newcomer in the family of applications that are available within C3S is the ERA5 Explorer. So I really invite you, if you have just a few minutes to look at this application. You have 80 plus years of data at your fingertips and lots of statistics that you can look at all over the world in a very easy way, where no technical requirements are required to produce quite elaborate maps. So lots of data available, lots of services. Let me move now very quickly to CAMS. So CAMS is working on atmospheric composition. So there are aspects of atmospheric composition that are very relevant for adaptation. Chris mentioned heat. Air pollution is also one aspect which can be exacerbated by changing climate. Particularly, so I won't go into detail on how this is done. This is also combining satellite observation, in-situ observations, and modeling. Let me give you 2 examples that are very relevant, I think, for Turkey in particular, is the impact of sarin dust. And CAMS is monitoring sarin dust and the impact of sarin dust on air composition. So this flows from the global scale with all the sources in Sahara, and then with higher resolution, the impact on the world floor and Turkey can be assessed. Also, in the context of climate change, the impact of wildfires is also an area where, using satellite observations, CAMS can forecast and the impact of wildfires, both locally, and here is an example of non-local impact. It was fires in August 2024 in Canada, which were having impact all across the Atlantic up to Europe. So like for the climate data store, there is an atmosphere data store, so users can go and get the data, make their own plots their own analysis with the data, which is fully free and open, so please have a go. My final words of this presentation is to say that what we are building now is to work on detecting emissions using observations. So this is something very ambitious, and this will be a pivotal cornerstone in mitigation activities. So the aim is to monitor anthropogenic CO2 emissions using observations. This is taking place in Europe, but more widely in the context of the initiative which is called Global Greenhouse Gas Watch, which exactly aims at this. So this is only the European effort, but North American colleagues, Asian colleagues also are working on that. In Europe, we started quite early, so we have already some products which are available. So I mentioned also some easy-to-use applications. You can see some estimates of emissions. I took the example of Istanbul there. You can see the estimates which are based on estimates of activity levels in different sectors, 12 in total, to assess the CO2 emission of Istanbul in that case. So that's based on activity levels, so energy, transport, etc. The other application which is already really available is the monitoring of methane emissions, and particularly methane emission hotspots. So this is also an application that you can have a look. So how we do this is we use satellites to detect where emissions are particularly high. You can see here an example which was a few months ago in January. We saw some very big emissions, and we could track these down to a volcano area, which actually was not known to emit a lot of methane. So we are learning a lot with this methane emission explorer, and also it's very useful for countries or cities to see very high emissions of methane, which is very important with gases as you know. And it's in the work to have a similar facility for CO2 emissions, but for that we need new satellites which are planned for launch in 2027. And my final slide is to show you also an easy-to-use application and to use the situation of today. So this is the forecast of aerosol just now. You can see here a band that is coming across North Africa and France, and already on Sardinia. So it's the situation now. In fact, our system says that it's mostly dust that is coming, and in fact it's a plume of dust that is traveling eastwards, and in our forecast from 27th of March, which is the forecast for the end of March 26th, very likely Turkey will be under quite a strong tone of dust affecting most of the country actually in more than 4 days time. Thank you for your attention.
I think all across to Dr. Vincent Henry Porsche as well. I was particularly very excited to see the excitement of our colleague from Istanbul Metropolitan Municipality, who just presented the information of climate action and mitigation from Istanbul, and she was very eager taking a photo of your presentation. I think that is one of the reason of this session, how to make these kind of tools accessible for city officials, for city managers, both accessing to this data but also providing input to this data. And I think by having your experience, Cihan, you can really help them to make it much more interchangeable so that this data is used both for preparing, but also decision making and action planning. I really would be hoping to have some questions or feedback from the room, because I know there's a lot of scientists who are here. Now you can see the room from this camera. They can intervene in Turkish if you want, and those who can speak in English, so that my life is easier. But if not, you can speak in Turkish and I can help with translation. Yes, please.
Zaten translation'da sorun olmaması için biz kısaca Türkçe söyleyelim.
Okay.
Sen devam et istersen.
Tamam. Okay.
Ben öncelikle Muğla Büyükşehir Belediyesi adına teşekkür ederim.
I suggest come to this group şuraya gel, seni görsünler. Çünkü bunlar... Hatta mikrofonu da. Mikrofondan gidelim.
O zaman ben İngilizce mi söyleyeyim?
İstersen Türkçe söyle. Ama önce
Okey.
seni görsünler. Şu kameraya bak.
Tamam, beni görüyorlar.
Heh, sen onları oradan görüyorsun. Tamam.
Thank you very much. My name is Can Dünya. I am the head of Climate Change Department of Muğla Metropolitan Municipality. Thank you very much for your attention, for your participation. We are happy for your support and cooperation. I want to say now we are using the Copernicus outputs, model outputs. Now we are preparing a web page that includes the seasonal forecast, some 6-month forecast, seasonal forecast, and also the quality forecast like pollen forecast. I hope we will open our web page at June of 5 June.
This is for Muğla.
For Muğla.
This is special for Muğla.
Special for Muğla, but covering the western part of the Turkey.
And are there any Turkish cities who have this information available on their website?
Not city, not government.
Okay.
This is the first. This is the first. This will be the first. So, on the other hand, the drought and the heat wave is also another problem. We have a plan to include these parameters in our study, and maybe we can finish them at the end of this year. Thank you very much again. Thank you.
What we can do, if you like, we can compile a couple of 2 or 3, and then you can have a joint response to all of them, if you like. Any other questions? Salondan katkı vermek isteyen soru, bilgi anlamında veya paylaşım anlamında. Oradan bile görüyorum. Lütfen kendinizi tanıtırsanız. Mikrofon var mıydı acaba? Yok mu? Olabilir. Geliyor. Galiba yukarıdan. So we have one question. Onun olduğu mikrofonlar onlar duyacak mı? Duyacaklar. Okey, tamam o zaman sen İngilizce söyleyebilirsin sürekli sanırız. Mikrofon yok mu? Bu mikrofon.
Hello, this is, well, you see me from very far. This is DEÐİŞİKLİDİYLE. I'm the Vice Chair of Global Climate Academy. It's an NGO based in Muğla. My question is to Mr. Wilson Henry Posh. I hope I translated your last name in the way. So, I'm always curious about Copernicus because I find it very interesting that from the satellite you're able to monitor GHG emissions of regions, cities. And I'm really curious whether you made a study how much each country's GHG inventories diverge from your calculations through Copernicus. If you made such a study, I don't know if it's possible because I mean you look at the geography, you don't look at the borders. But if this is possible, I'm really curious to know the answer. Thank you.
I suggest we can have one last question because time is a bit passing quickly and our colleagues are there for a long time. I'm particularly looking at Bayram Hoca, Tuncay Hoca, Ahmet Hoca, Gülem Hocam, Yaşar Hocam, Ebru Hanım. Eğer varsa katkılarınız bence yararlı olabilir. Yaşar Hanım, buyurun.
I would like to thank all, and especially for CAMS, the Copernicus service. As a scientist, I'm using especially the dust forecast for the CAMS global atmosphere model, but I was curious about, you showed at the last slide that there is a methane source that will be available, I guess. The dust products are excellent, but I was wondering when will be the methane and other greenhouse gases will be available for maybe forecast and for, let's say, small granules of data will be available. Thank you so much.
So, what I suggest, since the last questions came to Copernicus, Let's start with Dr. Porsche, and then we go the reverse order. We go through with Dr. Hill so that he can share. And as the last round, maybe we can have from Dr. Tüfeş'e a Turkish response, whether she would like to have any suggestions like a generic or overall roadmap, considering that you will probably be more often in touch with the colleagues and scientists here. If that's okay, so let's give the floor to first Dr. Porsche.
Thank you very much, and thank you for the question and very kind comments. So the first, so we're very happy to see a uptake of Copernicus in Turkey and India particularly. On the very good question about estimating greenhouse gas emission at country level, I think we are on a journey. In the sense that for methane, there is already in space some satellites that have a good capacity to monitor methane, while for CO2 we still need to have more satellites. So in general, we do what is called inversions. That is, because the satellite don't measure emissions, the satellite they measure radiance through the atmosphere, and we need models to infer what are the emissions that are most appropriate with the observation from the satellite. And we don't believe that this way of estimating emission is necessarily much better than the way, so it's called top-down, that the bottom-up way, which is the way the cities or the countries look at the emission sources. What is very useful from what we are providing is that it allows to see whether things can be reconciled or not. And so it's the way we present this is more monitoring and verification support capacity to make sure that in the assessment, in the end, what we want is that the assessment at country level or at city level matches with the observation so that we are sure that that's properly done, rather than to see a service which would be like a big brother, okay, these are your emissions. I think we are very, very far from that. So then in terms of countries and cities, it will really depend on the observing system. For now, the observing system, particularly for CO2, is very sparse, mostly in situ. And so we cannot say many things at the level of a small country. So Turkey is a big country, so it's an opportunity. But for many countries, they are too small, so we can say things at the scale of big regional land masses rather than at the level of countries. With the new satellites, the CO2M, which will be launched in 2027, certainly we have much more capacity to go into detail to look at that. And yes, the end goal is to make sure that we can reconcile or identify on the global map where there are the biggest discrepancies, so that the countries, but also the academic community can look at these areas where there may be discrepancy between what we estimate as emissions and what satellites see in the atmosphere. The second question was about the availability of data. So all data I've shown is already available. So the methane spot explorer is available. So if you go, I have provided my slide. So if you go to this app, you will be able to see the emissions just back from 1 week time. And so you can follow these the hotspots on a routine basis, and you have also a time slider to look at the data. So please have a go at looking at all these what I call easy-to-use applications, and or directly on the climate or atmosphere data stores. And very happy to be a point of contact for you if you have questions, so that we can maximize the use of Copernicus data in India, but also in Turkey.
Excellent, excellent. Thank you very much. Dr. Hamid, your closing remarks, and you can comment on the questions or points that was raised, of course.
No, thank you. I'd like to make some remarks, so thank you very much for inviting me and for the questions. So we're the World Meteorological Organisation, so we operate around the world, so I'm delighted that within the region that we're engaging closely with VCMWF through the Copernicus Climate Change Service, hopefully also with the Turkish Meteorological Service as well, so that's we represent Turkey in our organisation. So no, fantastic with the activities that are taking place within the region. We're engaged with the strong regional partners such as ECMWF and hopefully across the national partners as well. And on a personal note, I think that's obvious to you, I'm sorry I can't be here. I remember very fondly being in the region in 1985, I think it was, on a family holiday. So I have very fond memories of the region there. good luck with all of your activities around the climate variability and climate change. Thank you for inviting me.
Excellent, and maybe we can continue in touch so that on the 5th of June, World Environment Day, Cihan can invite you to give a comment and quote and celebrate the first ever city data, the meteorological level, meteorological data at the city level. Could be a nice demonstration of the environment and the climate services of the meteorological community available to the public, and I think that could replicate to Turkey and other countries in the world. Okay. Şirin Hanım, isterseniz Türkçe, isterseniz İngilizce, however you wish. This is the closing remarks for you.
Öncelikle hükümetler iklim değişikliği IPCC olarak hepinize teşekkür ediyorum. İklim değişikliği başkanlığı da hükümetler iklim değişikliği sürecine ülke temsiliyeti noktasında katkılar veriyor ve şehirleri, toplumu desteklemek için onlar da veri tabanı ve senaryo çalışmaları yürütüyorlar. Öncelikle yol haritası ortaya koymak istedi moderatörümüz Yunus Bey. O yüzden 3 noktada bir yol haritası koymaya çalışacağım. Öncelikle şehir akademisyen sivil toplum işbirliği oldukça önemli ve anladığım kadarıyla takip etmeyi çok arzu ettiğim bir konu olan 5 Haziran Dünya Çevre Günü'nde açıklanacak olan o web tabanlı veri portalı çok değerli olacaktır. Diğeri şehir arasında işbirliği ve öğrenme. Kardeş şehirler veya Türkiye'de bütün dünyanın nerede olursa olsun şehirlerin birbirlerini öğrenebileceği çok büyük potansiyel var. Ve son olarak da 3. nokta azaltım ve uyum arasında eşgüdüm. Çünkü bu seviyesinin azaltılması gerçekten çok kritik. Görüyoruz ki her ne kadar uyum çabası içerisinde olsak da dünya olarak gittiğimiz yol uyuma çok elverişli değil. Ne kadar uyum sağlayabileceğimiz de bir soru işareti olmaya devam ediyor. Dolayısıyla sevgi ısılığının azaltılması oldukça önemli, oldukça kritik ve bunun için birçok fırsatımız var. Yeni enerjiden, güneşten, rüzgardan, jeotermalden ülkemiz oldukça zengin, biyokütle dahil olmak üzere. Dolayısıyla uyum derken de azaltımı her zaman bir eşgüdüm içerisinde yürütmemiz oldukça önemli. Dolayısıyla bunlarla teşekkür ederek bu kısmı sonlandırmak istiyorum. Sağ olun.
Çok teşekkürler Şirin Hanım. İki belki de ek bilgi vermemizde fayda var. Başkanımız Ahmet Aras bugün aranıyor ama özellikle bu toplantı çıktılarını takip etme konusunda son derece kararlıydı. Bu toplantıya Halil Bey ile davet ettik. İklim Değişikliği Daire Başkanı Halil Nasar Bey. Kendisi de zaten İKLİM ve diğer çalışmalarda hep bizimle beraber yurt dışı görevinde de gelemedik. Ama zaten bu çalışmaları bilgilendireceğiz. Muğla'da bugün İKLİM'in 25. üyesi ve İKLİM ile IPCC Observer Organizasyon olarak zaten hem rapora hem de diğer süreçlere katılacak. Dolayısıyla buradan devam edebiliriz. Apologies for our colleagues, but sometimes it's always good to have it in native language, and there's nothing secret or hidden, so it's the same information that you're familiar with. I think we're at the end of our session. If you were here, you would be invited to the podium to receive your delegations of or declarations of participation or katılım belgesi. Did you prepare for our experts online?
I don't think so.
You don't think so? Well, what I suggest, if you still one more minute, yeah, first of all, we have a commitment from the head, Cihan, that they will send you your documents. It's signed by the mayor. But as a gesture of respect, I'd like to invite you to, we can turn off the görüntü, şurayı kapatabiliriz. Onları tam ekrana alalım. Cihan Bey ve ben Yılmaz Bey'i buraya almak istiyorum. Onlar adına, onların sanki belgelerini almışız gibi ama fotoğrafta onlar da olsunlar. Öyle bir fotoğraf çekelim, öyle bitirelim. So we will take you to the screen, three of you. We will have the previous declarations as a demonstration because it will not be real in any case, so don't worry. And the real original ones will come here, but we will have a family photo with all of you on the screen with your cameras on if possible. Okay. Birer tane verin elinize. Tamam. Ya da bir tanesi. Ha, öyle göster. Şöyle gel. Sen de gel. O şeyi kapatabilirsiniz.
O bağlantımız Yunus'ta yok.
Ha, pardon. Okey. Tamam. Şöyle yapalım.
Bizi görecek mi?
Yok. Şurada olacak. Orada. Pardon.
Yok, sizi kameradan oradan görüyor.
Tamam.
Zor olacaksa bu kameraya da alabiliriz.
İşte bu kameraya, şuraya alın.
Tabii buraya
o zaman
buyurun.
Görecek.
Evet, tamam.
Yalnız bir ihtiyarız.
Aynen. Sakata gelmiyor.
Burası kamerayı açalım.
Tamam. Sen ortaya gel. Sen vereceksin. Evet, şöyle üçünüz adına. Okey. Süper. Tamam.
Ekran, nasıl olsa kayıt alıyoruz.
Okey değil mi? Evet. Applaus. Thank you. Bye-bye. Şimdi bir dakika. Bir soru var. Bir de sen son bir saat değerlendirde düşünüyorum.
Yok hayır. Son bir saatimiz var. Orada rahat konuşalım.
O saat.
O saat. Şu an
Yani bu saatten kalabiliyoruz.
İstediğimiz kadar kalabiliriz. Salonun sorusu olduğu sürece. Yani serbest zaman artık. Sevi Hanım'ın bir sorusu vardı. Sen geç istersen buraya.
Sen de gidiyorsun. Ama ciddi mi?
Yok yani serbest zaman. Buradayız. Hani
Tamam.
devam etmek isteyen sorular varsa devam edelim.
Hocalarımızdan eğer öğleden sonraki yoksa gideceğim mi? Öğleden sonraki oturumdaki konularla ilgili su vermek üzere öneriniz varsa belki onları duyabiliriz. Uzun olmak zorunda değil. Hani değerlendirme yapabiliriz ama yarın ki oturumda nasıl yapacaksın onu bilmiyorum.
Ama birkaç şey söyleyeceğiz ama aslında bizim için değerli olan buradan aldığımız bilgiler. İşte genel konu yapacağız ya oraya yapacağız. Asıl şey oradan çıkıyor.
Seviyorum. Sorunuz bir daha tekrarlar mısınız?
Tabii. Yunus Bey, kendi aramızda da tabii sonra değerlendirebiliriz. Zaten bir arada olacağız. Belediyelerimizle de
Yani buradasınız.